This video will cover the superposition of electric fields. Since electric field is a vector quantity, the net electric field at any point P is the vector sum of the individual fields. To find the net field, first calculate the magnitude E for each charge, determine the direction of each field vector, and then sum the vectors. Let's work through practice problem 4, finding the net electric field. Two charges are placed 1 meter apart. Charge A is positive 3 microcoulombs, and charge B is negative 3 microcoulombs. We need to find the net electric field at point P, which is located halfway between them, 0.50 meters from charge A. Here is the solution to problem 4. We calculate the electric field from charge A and charge B using the formula E equals kq divided by r squared. Due to the equal magnitudes and distances, both fields are 1.08 times 10 to the power of 5 newtons per coulomb. Both directions are to the right, so the net field is the sum, which is 2.16 times 10 to the power of 5 newtons per coulomb, directed to the right.